Hey everybody, how you guys doing? Yes? Woohoo! Let's go! All right. So, we're going to talk about the rather boring topic of healthcare predictive analytics in the OR. But the reason why it seems boring, it's actually quite important because if we actually do this right, we can actually not only save companies money, but we can also help patients. So that's actually the context of this particular presentation, okay? So for starters, I wanted to talk about my partner in crime, Ayad Shamut. He unfortunately was not able to make it due to family issues, family concerns, but he's the Director of Business Intelligence at Beth Israel Deaconess Medical Center. That's one heck of a phrase to say, but the context is that he's actually part of an organization with the Harvard Medical Schools. Okay, and prior to working on this particular project, of the many projects he has, he actually helped build high available disaster recovery systems infrastructure at Beth Israel. Okay, so he actually was a transactional guy that shifted over more into the data sciences world. All right, a little bit about myself. I'm currently a technology evangelist at Databricks. I'm a former senior director of data science engineering at Concur, which is an SAP company, and I also happen to help bring Hadoop into Microsoft, part of the Hadoop on Windows and Hadoop on Azure project, actually. So just a little bit about me. So, oh, by the way, as we go into this a little bit, if you have questions, by all means ask. It's only 15 minutes, but a lot of this is actually setup slides, okay? So a little bit about Databricks. If you don't already know who we are, we're founded by the Apache Spark creators. We're the largest contributor to the Spark project, committed to keeping Spark 100% open source. And Databricks itself is an end-to-end hosted platform. Okay, so come talk to us. If you have any questions, we're in the green shirts. All right, to the meat of the topic. Okay, so when it comes to the operating room, okay, it's a valuable resource, okay, within a hospital, okay? Basically, for a basic surgical procedure, it costs somewhere between $15 to $20 a minute, okay, to basically run the system. So a tad on the expensive side. So they have to make sure this resource is managed correctly. Or basically, operating room efficiencies differ depending on your staff, okay? So basically, they in different hospitals have different categories or structures, but at least for Beth Israel, it's organized in 8, 10, 13 or 16-hour chunks, okay? And so it's not based on the workload. In other words, the number of patients or number of surgeries that you have to do. It's actually based on the staff that you actually have on hand, okay? And basically, the lack of OR availability basically means it's the loss of the patient, loss for the patient, okay? Or loss of the patient. In other words, they're going to go to a different hospital, okay? I mean that way, not the other type of loss, okay? Sorry about that. All right, but basically the context is time is the OR's most valuable resource, okay? And so the context, it's a little hard to sort of grok, so don't worry, the slides are available for download, okay? Basically, it's a really good quote from Dr. Stephen Schaefer. He says, "You're not going to get the elephant," and which is sort of ironic, being Spark and Hadoop, but anyways, the elephant to shrink or change its size. Okay, you either need to face the fact that the elephant is 8 OR tall and 11 hours wide. And what I mean by that, in other words, if your staff is set up, that means you only have 8 rooms and you have 11-hour shifts. That's it, okay? You can do whatever you want with that, but that's all you have. You have 8 rooms and 11-hour shifts, okay? Because you can't magically produce surgeons out of nothing or having enough of a staff, okay? And so why is this important, okay? In the case of, from the standpoint of the operating room, you've got better utilization, which means better profit margins. And also, interestingly enough, reduced support and maintenance costs. It's actually, because when you have an operating room, it's not like if you have 3 operating rooms, you can all of a sudden have only 1 person maintaining the equipment, okay? Versus, 8 operating rooms, and now you can still have 3. You're gonna need 3 people to maintain it because of the specialized equipment. You don't have much of a choice in the matter, okay? So the fact that if all the operating rooms are being utilized correctly, that means your actual maintenance costs actually are going down, or at least utilized more efficiently, okay? In terms of medical staff, basically better utilization means better profits, okay? It's not just better for profits though, okay? From the hospital or the various organizations, that's true, but also better efficiencies. And what I mean by better efficiencies is as in the surgeons, the nurses, the staff actually become more efficient and better at what they do because they're doing it more often, okay? There is plenty of empirical evidence that showcases this fact that the more, just provided they're not overworked, the fact that they're actually doing more of these sessions, in fact, make them better at doing their job. Okay? And actually, God forbid, we're actually helping patients. Okay? In other words, shorter wait times and less cancellations. And because you've got better medical staff efficiencies, you've got better outcomes. Okay? So basically, it's a win for everybody. All on this on this thing about how to schedule your operating room actually results in all these different efficiencies. Okay? So what Beth Israel was trying to do was to go ahead and how to figure out how to develop a better predictive model. Okay? And so basically, they would identify the OR times 2 to 3 weeks in advance. That's typically what they're doing. And they will allow us to confirm wait list cases 2 weeks in advance instead of when the blocks were normally at least 4 days out. So in other words, instead of actually trying to make decisions 4 days in and then basically trying to cram people in at the last possible second, can we go ahead and predict that there was this much available time slots 2 weeks out so we can actually start calling patients to come to the hospital earlier? That way they had less wait times, they didn't have to wait as long, and the surgeons were actually doing a better job. Okay? All right. So basically, the forecasting schedule was, again, 3 weeks out. We booked more case weeks in advance to prevent underutilization, and we also reduced staff overtime and idle time, which was actually a key problem for us as well. All right? So the quick background is initially they were using 3 surgical pools. That's fine. Okay, basically they're listed right there for you. Okay, but what was interesting about it also was that they were actually built using SQL Server data mining. Okay, because Beth Israel actually is a Microsoft shop. Okay, so it may surprise some of you, but then basically some of the high availability disaster recovery systems they actually had for surgeries was in fact built on SQL Server. So they naturally went over to SQL Server data mining. Okay. So the concern with that is that it actually got a little complicated, okay? This is just a part of a diagram of the process flow that what they had to do. So basically, they had to update a bunch of tables. They had to go ahead and do multiple loops. I'm not actually going to go into all the details, but suffice to say, they actually had to build 75 separate packages for 75 different models, maintain them separately in order to be able to start doing predictions. And so Beth Israel, Aisha Mood, and I had been working together for a long time when I was actually part of SQL Server. And one of the things that we realized is that we could gain a lot of efficiencies by running the stuff in Spark as opposed to running the stuff in its current form. So that's what we decided to do. So I'm going to give you a quick little demo. And in all seriousness, for everybody that's sitting in the room who actually is a data scientist, this is just linear regression. Okay? That's actually all we did. Okay, to predict the amount of wait times that were going to be available 2 weeks out, up to 2 weeks out, excuse me. So let's jump into it. Okay, so what I'm going to show you is on top of Databricks, okay, just because it's a very nice visualization for us to work with. But in reality, you could do this in Spark, and in fact, that's how we initially had built it too, okay? So it's just that it's a lot easier to look at when we go ahead and built it in Databricks, so hence it is, okay? So all we did was initially build a data frame. This class, OR booking time history, I apologize if you're not able to read it very well, basically it was just information about the history of what rooms were used and how much available time was left, okay? And then what we did was build a data frame to basically extract that data, okay? That was it, all right? And then what we did was then build this OR booking time history table, okay? So this table basically is this query right here. So if I'm to look at, excuse me, there we go. If I was to go ahead and look at, for example, just the schedule from April 1st, 2015 onwards for group ID equals 1. There are 3 group IDs, 1, 2, and 3, so group ID equals 1. You notice that, for example, there's a lot of time remaining on Friday, not so much time remaining on Wednesdays, for example, okay? So the context basically of this is that we chose 3 independent variables. And in this particular case, for this particular hospital, the 3 independent variables were day 5, day 20, and day 30. In fact, we were experimenting with different days. In some cases, there were 6-day variables. Some days were 3. It's actually a very long and tedious process that we went through, but basically what it boiled down to is that we realized that at least for the Beth Israel Hospital, 3 days was enough to start predicting what we had, okay? And so, all right, So, and then for example, if I was to look at group ID equals 2, which is basically a different group of departments in terms of the OR hospital, so in terms of the OR rooms, basically, again, here's the grouping. This is a little bit more even. Basically, every single day, they actually have roughly the same amount of wait times or available times, okay? So all that we did here is to say, okay, well, I'm going to build a new data frame, okay, which is this part right here, which basically says, okay, let's see. And we're going to go ahead and set up MLlib. All right, so that's running here. Okay. And with the features being, oh, sorry. There you go. Day 30, day 20, day X, and the label being day 5. Because these were the days that we thought that we could best use to predict the number of days or the amount of time that was available within the OR. This particular example here, query here, is basically just simply parsing the data. And if I go ahead and look at the data, basically that's this is it parsed out where what you see here is the day X, and these are the different independent variables, okay? So in other words, this is actually very, very similar to the linear regression that you actually literally see on the Spark website, okay, documentation website. In fact, we didn't do much more than that. That's all we in fact did, okay? We also did feature scaling because the number of days between day 5, day 20, and day 30 were very different. They were actually different orders of magnitude. Typically, at day 5, you have a lot less. Day 20 and day 30, you have a lot more times available. So because of that, we actually used feature scaling to scale it down. Okay? Oh, sorry. And then we train the model. So I'm not going to run it because it actually takes a minute, okay, on my small cluster. But basically, we experimented with different iterations and different step sizes to see if we could actually go ahead and predict. And then when we scroll through here on the historical predicted versus actual, what we're able to basically show, this result here, is actually what was predicted and what was the actual amount of time. So using some nice quick graphing, because nobody wants to try to make sense of that text, okay, we basically just plotted it out. And more or less the predictions and the actuals were actually quite aligned with each other, which was awesome. Because in fact, we were really concerned when we were originally doing this project that we would not actually do a decent job predicting. So the long story short is that how we got to 3 variables was because we just kept on plotting this out, running mean square error calculations and plotting it out to basically see how precise or how well the predictions were, okay? That's all we end up doing. And so ultimately, when I flip down to here, and by the way, the slides themselves actually contain screenshots of all this stuff. So in fact, actually, the context is actually all still here. But what it boils down to, I'm just going to skip right to this part, is that we were able to go ahead and predict that there was 478 minutes available, okay, on a particular day, and the actual fact was 546. Okay? Now, that might seem like an off prediction, but the reality is that because we were able to predict that, we were then also able to fill up the OR slots with those 478 minutes. And in fact, 478 minutes is great because we actually wanted available buffer time, because when you flip between different surgeries, okay, you actually needed buffer time that was never calculated. So we actually wanted that number to be about 80 to 90% of the actual number, and that's exactly what we got, okay? And so that's, in a nutshell, what we did was go ahead and use Spark to do linear regression against this data set, so that way we could actually start predicting ahead of time on how much available time was in the OR, so we could start filling it in. So that way it was not only resulted in better utilization, but also better patient outcomes, okay? Because we were able to actually help our patients a heck of a lot better, okay? So I'm going to flip back to the slides because I only got about a minute, I think. Yeah, okay, sorry about that. And so this is an example report that they basically look at. This is built off of that. This is using reporting services, but the back end of Spark, don't ask how we got into that process, okay? And basically the context is why are the models working? It's because we can coordinate waitlist scheduling logistics with the physicians and the patients, okay? And we can actually plan staffing resources, which was really important. And basically the utilization metrics were very clear that basically it showed us which were elective schedules, OR schedules, versus which were actually necessary components. And we could actually basically balance that out. And fortunately, because of this process, we're actually able to help a lot more patients now. So that's actually the bulk of the presentation.
What was the scale of the data you were working with, and if it was small enough to fit into a SQL database? Why was Spark the right choice over a non-distributed system?
No problem. The question is how big was it? It's actually relatively small so that it could fit in within a SQL Server database. That is correct, okay? The reason we want to use a distributed system is because this is not actually just going to be applied to Beth Israel. Beth Israel is our starting point. We're actually going to be applying that to multiple hospitals. At that point, we're definitely going to go well beyond the bounds of a SQL Server. And even if we were able to stay within the bounds of one, the idea that we could just chuck the data at AWS, have a system being maintained for us, made things phenomenally simpler.
Quick question.
Oh, sorry.
How did you, I guess, measure the performance for overruns?
I'm sorry, I'm having
Actual overruns in the OR room? How were they, if a surgery ran long?
I'm sorry, I'm having a hard time hearing you. Sorry.
How did the overruns in the actual surgery time get?
Oh, how do we take into account of overruns? Oh no, that's the predictions that we're doing was based on how many minutes overall per day, as opposed to any particular surgery itself, right? We were only saying if a particular day there is 300 minutes available. That's all we're trying to do. And so the idea is that you would schedule people to come to the hospital maybe the day before or 2 days before, so they would come. If there's a surgical overrun, we weren't going to tell them precisely at 1 o'clock you're able to do it. But because they're already at the hospital, right, they might be able, maybe we can't do it today, but we can do it tomorrow now, right? That's the context, because that's why it was so important for us to know the number, not just for a particular day, but for 2 weeks in a row. So the most a particular patient was waiting for was actually 2 weeks.
How often is this model built?
Oh, how often is the model refreshed? It's actually refreshed daily. Yeah, we have to refresh it daily because when it comes to OR systems, we're constantly updating the information. Yeah. So.
Other questions? Other questions? Yes.
So like in the OBGYN, for instance, women might get a C-section just because the doctor is kind of inept. And I wonder if you looked at like physicians that are actually working on that day.
Oh, right. Okay, so did we go to the point of actually predicting particular physicians in relation to the OR scheduling? No, we haven't. Okay, but similar in vein with what you're talking about, we've actually, this system has been so successful, now we're worried about capacity of staffing. So we actually have to figure out, can we get the staffing to step up when we do predictions like this? And then exactly to your point, that's actually what we'll have to do. I don't think it's next, but probably next. In terms of actually associating particular types of procedures and the type of and the doctors or the nurses or the staff that's associated with those procedures. Yeah.
Cool. Alrighty.
Cool.
Okay, great. We can take other questions offline.
Yeah, questions offline. Thank you very much.
Thank you very much.